So guys, today in this video I'm going to talk about something I have been building lately. This is a shift register, right shift register, which I made using discrete logic. So I have D flip-flops which are arranged in such a way that it is kind of uh, making a shift register. So yeah, this is really big and you could get ICs to do this thing, but just wanted to make this thing, right? So this is basically the Q, and the Q dash is you know given to the other register as the clock, and Q is given as the input, and kind of it shifts. At last it goes here, and here the data just goes away, like. And here we have the clock signal, and here we have the data signal, and here are two wires. This is the black wire, this is the ground, that is the ground, right? And here we have the positive, this is a VCC, and I would like to give it around 3.3 volts because I don't have any current limiter resistors here. So that is good. And if we take a look at the data sheet of this is a 7474 dual positive edge triggered D type flip-flops, and you can see the diagram here, and you can see that there are multiple pins, and you have to configure in such a way that it does output. So it has to be given the VCC and ground, of course, and you have to give the clock pulse, and you have to disable the clear function. Then you have to give the D, and yeah, basically D, right? So yeah, that is that. And this is dual flip-flop, so you can see that one is driving two LEDs. So yeah, right. So that is that. Here we have uh, the truth table for that. Anyway, I got a data sheet of another IC here. Let's take a look. This is the 74AC595. So this is like, it can also be 54AC595. Yeah, both are kind of little bit different, that is it. Anyway, this thing actually has a diagram for this. So shift register, and you can see the D flip-flops making the total output. So this is a flip-flop stage, and you can see there's a buffer stage, buffer stage, and that is here, right? And there are multiple like this is a little bit complex. You don't have to build this much, but this always has multiple features, right? You can disable outputs and enable outputs. You can do tri-state, so it can basically disable the output as a whole, like it doesn't even be like it is loading the circuit, right? For example, you have a bus which is connecting your CPU or something like that, then you don't have to load the total bus, right? You don't want to load the total bus, so it should be in the tri-state. That is where it is in high impedance mode, so it is not driving anything. That can be done with this. So that is why there's, like, so many circuits here, and the NOT gates and everything is not needed if you want to just build a shift register. But building a shift register will give you a good logic and good understanding about how it works and everything. But if you want to use it, it is kind of awkward, like you don't want. So you can see a single IC has 8 bits, so that is 8 bits. So let me show you a project I have been working on. So just moving around here you can see a project. This is basically a display I am making using shift registers. So kind of what I am doing is I am having everything in parallel, right? Like all the data and clock pins are all tied together using this breadboard, and it is driven by this Arduino is basically giving it a clock pulse, and sometimes the data goes slow, so it goes slow for 4 clock pulses, then it shifts it, and it is basically 4 clock pulse, data is high, and 4 clock pulses the data is low. So anyway, you can see all the shift registers here. So this one drives the lower one, and this one drives this one, and this one drives the third one. I haven't finished it yet, so this can't be a driver at this moment. I'll be writing a driver for this so that I can add in the computer also, like as a computer screen or something like that. But it is not real functional, but for the purpose of just making a display, it works, like learning purpose, right? uh, and you can also see that there are only 5 ICs, because I do have one in here, because I did check with the breadboard first before making the circuit. So that is working fine, everything is perfect. This is powered by the bench power supply, which is giving 3.5 volts, you can see, and around drive current is like 200 milliamps. So that is all perfect. If we take a look at the data sheet, uh, the other part of the data sheet is here. So this is a data sheet. You can see the pinouts. So in the pinouts, one thing you can see is that there's VCC, ground, and there are like multiple clocks. So what I did was I did put this signal to low. That means this signal to high. That means it is not in clear state, so it doesn't clear. This is like a reset state, and here you can see serial clock and R clock. So these two clocks basically mean a different thing, which you can get from the data sheet. I didn't figure it out, because I was just going to build this register circuit with that. So for my purposes, I just short both. You can read the data sheet and understand whichever that is, and maybe you can play with it. It doesn't really matter, like how you learn. But at last you get QA, QB, QC, QD, QE, QF, and QG. Not and QG, like QG and QH. So it's like 8 outputs. So you have 8 outputs. So this is a 10 bit shift register. So this thing took around like 1 2 3 4 5 ICs. So if I take this IC off, then this is like 1 2 3 4 ICs, and I have to wire everything to make it not clear and everything, right? So that is not so good. This is much better. This solution is much better. I'll be updating you on this project, uh, on how to write the drivers and everything. Like I don't know, it's my take on it. Like it may not be the original way people write drivers, but I like to design everything from base to top. So yeah, I hope this video is not awkward. And yeah, if you like me doing this kind of electronics, and if you want much more in-depth tutorials, then I can do that. But as I feel I don't have much views on these kind of videos, so I don't do much, right? Anyway, hope you guys liked it. If you did like, give a thumbs up. If you didn't like it, the button is there. If you want to see more videos like this, and mainly I do Linux stuff, so mainly this is a Linux channel, right? So if you want to uh, see more videos of Linux, or basically this electronics or something like that, then please subscribe, and goodbye guys.